Hi, I'm Dr. Thomas Blaine, Associate Professor with Ohio State University Extension. And today I'm going to be addressing some of the really tough questions, the hard questions about global climate change, global warming, and what kinds of things that we're very likely facing in the future. So stay tuned.
Hey, welcome to another episode of Earth is Our Home with Dr. Thomas Blaine. He's an associate professor with the Ohio State University Extension Program. Tom, it's always a pleasure talking with you. I learn a great deal when it comes to climate change and global warming.
Well, I'm glad to be doing these programs with you. Earth is Our Home, I think, is a series I'm really proud to be a part of, Patrick. And I'm very grateful to OSU South Centers for helping me create this series. I hope that we're reaching the public and really making a contribution to public understanding about global climate.
You know, Tom, with global warming, ever since I can remember, there's been a lot of hype about this. We have had a lot of CO2 emissions. You know, let's face it, back in the 17th century, 18th century, 19th century, with the Industrial Revolution, we have been throwing lots and lots of things into the air. And have we seen repercussions? No. People say that water will rise covering our cities. I've also read interesting things that the water will probably only rise 5, 6, 7 inches. And finally, and the question always comes in, economic growth or limited technology. It would be nice if we could all run to our caves and not worry about how we're damaging the earth. But let's face it, that's what we would be living in, caves. We have to have economic growth to sustain ourselves.
Those are great ideas, Patrick, and I appreciate you mentioning them because I think that your way of thinking on that represents almost everybody's way of thinking, including mine. I'm in the same era you're in. My whole life, I've lived with dependency on fossil fuels. The home I'm in now has air conditioning, powered by electricity. I drive an automobile. I've flown all over the world. You know, I have been, like most of the rest of us, had a better standard of living than any of our ancestors who came along before. The standard of living now is higher than it's ever been. The availability of food, a safe and abundant food supply. You know, much of human history has been a struggle to get by day to day. And now civilization came along about 6,000 years ago. About 250 years ago, there was a quantum jump when we engaged in the Industrial Revolution. And you're right, that's when we started burning quite a lot of fossil fuels. But because we have 8 billion people today, and in the early stages of the Industrial Revolution that you're talking about, 180 years ago, yeah, you can think about when they invented the steam engine and started using coal, but the emissions back then were literally nothing compared to what they are now. Why? Because the population of the world was a tiny fraction of what it is now. And most people in the world did not utilize the products of industrialization. So I've shown you before how CO2 concentrations have risen, you know, at the time of the American Revolution, concentrations of CO2 in the atmosphere were about 280 parts per million. 280. That's a good number to remember. Just remember 280 parts per million. They had been that for about 10,000 years, only fluctuating within a very narrow range, right around 280. They started going up very slowly in the early 1800s for the reason I gave you. They are now at 420, which is 50% higher than what they were before the Industrial Revolution. 50%. They haven't been that high in several million years, long before Homo sapiens came on the scene. CO2 concentrations are much higher now, and they're projected to go ahead because we continue to emit. They're projected to go ahead and be at 560, which is double the pre-industrial level by around 2080 or 2090. So, some of the changes we're making, they've raised questions, and I just want to make it clear a little bit here. Pretty much rule number one in science, what matters is reason and evidence. Doesn't matter if a professor says it or a student says it or whoever says it. If they've got reason and evidence on their side, there is a pretty good chance that we ought to pay attention. I want to hear the evidence. So I want to go ahead and talk to you, but I want you to, everybody's free to go back and look at the previous episodes. And I hope they'll do that, because sometimes it takes watching something 3 or 4 times to really get it. And as you know, those episodes are loaded with facts about the climate engine, facts about temperatures, CO2 concentrations, and all that stuff. The data is what counts, not my authority as an associate professor with OSU Extension. I mean, it does help to have credentials, because it is an indicator that I've studied this and I have my whole adult life. But I've got to be able to convince you, if I'm going to convince you, on the basis of evidence and reason. And that's what I take pride in. Well, today, since you raised this up about these topics of skepticism, I'm going to start tackling today the very tough questions on climate change. And so we're not dodging any bullets today. These are the most controversial questions people want to know. Again, I gave a lot of stuff about how the climate engine works. People are like, yeah, okay, it's interesting to know. But we've got these questions. Is there a climate catastrophe looming in the future? You're correct when you point out that the warming we've seen so far has mostly been benign. I agree. It's mostly been benign. And what do I mean by that? Agricultural yields have gone up all around the world. We're feeding 8 billion people. When I was a kid, we only had 4 billion. Population's doubled, and we're feeding people better than before. Most agriculture takes place outdoors. How'd that happen if the climate has been deteriorating through warming? Okay, so it has been benign, but what about the future? Is there a catastrophe looming in the future? You mentioned sea level. Is it about to flood our coastal areas? Is it too late to stop this? And is the fuss over warming just hype? And that's a word you used. So I want to answer these questions as thoroughly as I can, and I'm being honest and trying to give the very best take I have on the evidence. It took millions of years of the death of forests, vegetation, all that kind of stuff to put the coal in the ground that we have. Forests died, got laid down in layers. Appalachia was a coastal marsh. Then the mountains grew over top of it because of tectonic movement. And lo and behold, 300 million years later, we've got hundreds of millions of years of stored carbon under the mountains of West Virginia, Kentucky, Pennsylvania, and so forth. Okay. And we're taking out of the ground the carbon that was put there over millions of years, and we're burning it to put the carbon back in just a few hundred years. And that should grab your attention. As I pointed out, this has caused CO2 to rise to a point already where it's higher than it's been since before humans got here. Now, CO2 is a molecule. We need it in the atmosphere. The plants would die without it. But we were operating within a very narrow range for about 10,000 years. And now we're adding so much into the atmosphere, it's changing the composition of the atmosphere. You have to remember that CO2 blocks physically, the molecules block the movement of heat from Earth's atmosphere into space. Scientists figured this out not in the 1970s, 80s, or 90s. They figured this out in the 1800s. Svante Arrhenius, who won the Nobel Prize in chemistry, did a great paper on this in the 1890s. Before him, John Tyndall. These 19th century physicists and chemists showed the greenhouse effect long before my grandparents were born. This is not new. Okay, other things are changing as a result. We don't know. I don't have a crystal ball, but the thing about it is that the rate of increase in CO2 concentration appears to be very difficult to change. Very difficult. In other words, you can add windmills and you can add solar panels and things like that, but that trend just keeps going right up. And there's a very good chance that as we continue with this increase in concentrations, the benign effects by 2050, 2060, 2070 will start to turn negative because of increased warming as the temperature of the planet increases, which means what we're doing now by staying with fossil fuels, we're just taking an enormous risk with the future. Not really my future or your future, not even necessarily our children's, but our grandchildren's and great-grandchildren's future. We're taking a risk with them. Now, you ask about sea level rise. I want to be very specific. After the last ice age, the sea level was 350 feet below where it is now. You could literally walk from Siberia to Alaska. There was no waterway there. The sea level was so low because it had been so cold and there was so much ice. But once that started to melt, and that was natural, we started to get an increase in sea level to essentially what we have had, certainly by the time of the Roman Empire. It was fairly stable for a long time. Sea level rose 10 inches in the 20th century. That's about an inch per decade. That's what it's rising right now. So when people tell you, Miami's going to flood in 10 years, Miami could flood in 10 years, but it would be because of a hurricane bringing storm surge over the city. Miami's not going to flood in the next decade or so because of warming induced sea level rise. However, the sea level is rising at an inch per decade. With additional warming that we're seeing because of higher CO2 levels, the rate of sea level rise is very likely to increase to 2 to 4 inches per decade by 2080. And you can see where this will eventually take us. By the 22nd century, this would be something that would change the coastlines all over the world and flood cities. Not by 2050, not by 2080, probably not by 2100, but eventually 2130, 2150, because the rate of sea level rise is liable to increase, especially if we get a 4 degrees Fahrenheit in global temperature. Keep in mind, global temperature has risen over the past 100 years or so by about 1.8 degrees Fahrenheit. 1.8 degrees Fahrenheit. And it's causing more rapid sea level rise. So if we talk about a 4 degree Fahrenheit increase, we're talking about possibly having 3 to 5 feet higher by this time 100 years from now, 2121, because we could accelerate this sea level rise with, periodically very large chunks of polar ice falling into the sea. Now, a lot of this is unknown. We don't know precisely, as we add CO2 for every increment of CO2, how much the temperature will rise. We have estimates. Climate sensitivity is what we're talking about here. How much does temperature rise when CO2 rises by X amount? Well, the CO2 itself only plays a certain role. But when you increase temperature by, say, 1 degree Fahrenheit because of CO2, it doesn't stop there. We live in a dynamic Earth. When you warm the Earth, you get feedbacks, it's called. A feedback mechanism is something that happens as a result of something that led to it, something that previously changed. You change A, the system changes, but that system changes B. Well, with the warmer Earth caused by CO2, you get more evaporation from the oceans, right? That puts more water vapor in the atmosphere. Water vapor, like CO2, is a greenhouse gas. It traps heat. You also get the loss of albedo. Albedo is where sunlight reflects off of white surfaces. Where the poles are, it's white because of snow and ice. Sun shines on it, reflects back into space, doesn't contribute to warming. When a lot of that ice and snow melts, it reveals a dark blue ocean, brown on the land or green. And it's like why you wouldn't wear a black outfit on a hot summer day. Typically, you don't want to do that. And you don't want to lose the albedo at the poles or in Greenland or in the mountains of Switzerland. But if you replace a white surface with a dark surface, the Earth is going to retain more heat. That's a feedback mechanism. Most of the feedbacks that we see that I talk about now, the water evaporating from the ocean, the change in albedo, most of these seem to be positive in the sense that they amplify the initial change. So clouds are another feedback. They work both ways. Clouds hold heat in, but the top of the clouds reflect sun back. We don't know the net effect. Another feedback is what happens if we release methane from under the permafrost. If the permafrost begins to melt, we release methane. Or if under the Arctic Ocean, the shallow portions of it, there's a lot of CH4 methane there. If we release that, it will add to warming because it's a very powerful greenhouse gas. Is there a way out of the predicament? I don't think so. I don't think there's a way out of the predicament. I'm with you. I like our living standard. So I would like to preserve it. A lot of people say, let's go with green energy. But I have to say, I'm very skeptical. You're skeptical of certain things. I'm very skeptical of green energy. They're intermittent. Solar and wind are intermittent. There's times when you don't get any energy input. We can't shut the grid down. They're energy intensive to make, those solar panels. They require mining, which is a dirty industry, requires a lot of energy. The solar panels and windmills take up a lot of room. They destroy ecosystems where they're located. And, imagine having to keep a coal-fired plant online all the time in case the wind dies and the sun goes behind clouds. You can't just shut down a coal-fired plant on a sunny day when you're getting lots of sun and then that night turn it back on. It doesn't work that way. You have to keep that thing going the whole time. This is engineering, and it's just a fact. So nuclear power is one that is a potential solution. France has moved toward nuclear power. You pull your car in, they've generated electricity, charge a battery in your car. But we all know that nuclear power poses threats of its own. 3 Mile Island, Chernobyl, disposal of nuclear waste. Okay, so we're back down to your suggestion. And there are serious people that are suggesting this. I'm not one, but a lot of the people are saying, why did we pursue this living standard anyway? Why do we have a modern world with central heating, cooling, manufacturing? When we cut back everything on the economy, when we first went into pandemic lockdown, CO2 emissions fell and the concentrations kind of teetered. That kind of lockdown will work. Do we want to make a lockdown like that permanent and give up on the 21st century lifestyle that we have? That's an option, but I don't think it's an option many people many people don't want to live like their great-great-grandparents did here in Ohio, working on the farm and subsistence living and so forth like that. I don't think that's realistic, but there are people that are talking very seriously about it. And the pandemic lockdown of 2020 provided a preview of what this new world would look like. So I'm leaving you with a pretty bleak message. But that's the message I have today.
Tom, you're bringing up some really good points that you and I both agree on. And I think many people do agree. And I'd like to continue in the next segment in some of the other aspects that you're looking at and maybe get a handle on how we can slow down or prevent some of the catastrophic situations that you're outlining. Hey, we're talking with Dr. Thomas Blaine. He's an associate professor with the Ohio State University Extension Program. And Tom, thank you again for the information.
My pleasure, Patrick.